Okay, so this section is chapter 6, and we're going to start talking about pre-algebra. This video is going to cover section 1. And section 1 is the addition of sign numbers. So we're going to understand the meaning of sign numbers, and we're going to add sign numbers in this lesson. The meaning of sign numbers: the numbers to the right of 0, greater than 0, are considered positive numbers. The negative numbers are all the numbers that are less than 0. So if we look at this number line here, we've got 0 in the middle. If we go to the right, we're counting up in the positive direction. If we go to the left, we're moving in the negative direction. Think of the negative part of the number line as the reflection of the positive part through an imaginary mirror placed through 0. This means that ordering the negative numbers is the opposite of ordering the positive numbers. To indicate the relative size of numbers, we often use the following symbols. We're going to use the greater than symbol to see that A could be greater than B, and the less than symbol to symbolize that C is less than D. A lot of times teachers would refer to this as the alligator. Okay, I like to think of it if I come to the big part first. So if I'm reading a number and I come to the big section of the sign first, that would read 9 is greater than 7. If I'm reading along and I come to the pointed side first, the smaller side of the sign, that 7 is less than 9. On the number line, 4 is to the right of 1, so that 4 is greater than 1, and you would write that 4 is greater than 1. So we've got 1 here, and we can see 4 is bigger than that. On the negative side, it almost seems like it goes backwards. Negative 4 is to the left of negative 1, so that negative 4 is less than negative 1. So negative numbers are going to kind of move in the opposite direction of what you would think. In algebra, we also use the symbol greater than or equal to, and see it's got this little circle underneath there. That symbolizes the equal to part, and the symbol less than or equal to signify less than or equal to. The numbers we have marked, -4, -3, -2, -1, 0, 1, 2, 3, 4, they're called integers. When we work with both positive and negative numbers and need to use names to distinguish them from each other, we often refer to them as sign numbers. We use a minus sign to show that a number is negative. For emphasis, the plus symbol is sometimes used to denote a positive number, although the absence of any symbol automatically implies that a number is positive. Addition of sign numbers may be pictured using the number line. A positive number may be represented on the line by an arrow to the right or positive direction. Think of a positive arrow as a gain or of some quantity, such as money. The sum of two numbers is a net gain. So if I want to say 4 plus 3, which is the sum of 4 and 3, okay, we would start out at 0 and go to 4. And then we would say, well, we need to add 3, so we would move 3 in the positive direction, which would get us an answer of 7, which would mean that would be our net gain. A negative number may be represented on the number line by an arrow to the left or negative direction. Think of a negative arrow as a loss of some quantity. So for example, -4 plus -3, is equal to -7. And so on this case, so they went to the -4. Like on your number line, you would put your pencil on the -4. And since you're adding -3 to it, you're moving to the left 1, 2, 3, which would make your answer be -7. So you're starting at -4, then you're going to the left -3. People also write this, sometimes you might see -4 plus -3 just written as -4 minus 3, and that's also -7. Another way to picture addition of sign numbers is to look at it as white chips and blue chips. And so if you're having trouble with a sign number, you might find it easier to picture addition of sign numbers using ordinary poker chips. Suppose that we designate white chips to represent positive integers and blue chips to represent negative integers. The sum 4 plus 3 can be found by taking 4 white chips, which is what they've done here, and then adding another 3 white chips, and the total of that would be 7. Similarly, we could take -4 plus -3. Well, -4, since it's negative, that would be 4 blue chips, and then add 3 blue chips because 3 is negative here, and we would get 7 blue chips, which would indicate -7. So to illustrate -4 plus 3, to illustrate 4 plus -3, since 4 is positive, you would take 4 white chips, and -3 is negative, so you would take 3 blue chips. And then every time you have a white chip and a blue chip together, so they've just taken the 4 and lined it on the top, the 3 on the bottom, every time you have one of these that are a pair, they cancel each other out. And you'll see that you have one white chip left, which means the answer is going to be 1. So if we want to represent -4 plus 3, we would have 4 blue chips for the -4, and then we would have 3 white chips for the +1. And when we line these up, we're left with 1 blue chip because these cancel each other out, and so the answer is -1. If I was going to do these problems on the number line, so if we have 4 plus -3, okay, we would want to start our problem at the number that we started at, which is 4. And because we're adding a -3, and keep in mind that this could also be written just 4 minus 3, same thing, plus a minus is just minus, but it's saying add -3, and I'm sorry, I skipped 1. Apologize for that. Okay, so we started at 4, and since it's saying add -3, we would have to move back to the left 3, and so our answer is still 1. Just a different way of doing that. This problem says -4 plus 3, so we would actually start our number at -4, and then we would want to add 3, so we get to move to the right 3, so our answer would be at -1. To add or subtract sign numbers, you should work with absolute value. The absolute value of a number is the distance along the number line between that number and the 0 point. The absolute value of any number is always non-negative. So the absolute value of 4, how far is 4 away from 0? Well, it's 1, 2, 3, 4 units, and you'll notice it's positive. I have -5. Well, -5 is 1, 2, 3, 4, 5 units away from 0, positive. The answer to an absolute value problem is how far that number is away from 0, and it's always going to be positive. To add two sign numbers, first find the absolute value of each number. Then apply the appropriate rule. If the two numbers have the same sign, add their absolute values and give the sum the sign of the original numbers. If the two numbers have opposite signs, subtract the absolute value and give the difference the sign of the number with the larger absolute value. So, these two numbers have the same sign, right? They're both positive, +9, and we've got a +3. So they're saying, well, the absolute value of 9 is 9, the absolute value of 3 is 3, and when you add those two, you would get 12. And so our sign is positive because both numbers are positive. So if our numbers are -6 and -9, once again, both of these are negative, so they have the same sign. So you can say, well, the absolute value of -6 is 6, the absolute value of 9 is 9, and when you add those, you would do 6 plus 9, that would give you 15, and then because they're both negative, it's going to take on the negative sign. Okay, you could also use the number line to do that as well. Okay. So in this example, you'll notice that we have one positive number and we have one negative number. So the directions are to find the absolute value of each number. So the absolute value of 7 is 7. The absolute value of -12 is 12. And then you're supposed to take the largest number minus the smallest number. So they did 12 minus 7, which is 5. And then they decided that it was negative because you take the sign of the larger number. And since 12 is larger than 7, that means that the negative number is larger in the negative. So I kind of say that one wins because it's the biggest. So it's going to take that sign. Okay, let's look at another example here. If I did 5 plus -7, okay, I've got two numbers that have the opposite sign. So I would do 7 minus 5. I would take the larger number minus the smaller number and ignore the signs right now, and I would get 2. So I know that 2 is part of my answer. Which one's bigger, the bigger number, the 7 or the 5? 7 is bigger than 5, so it's going to take this sign of the 7. Okay, here's another example. We've got 22 and -14. Two different signs, one's positive and one's negative. So what you want to do first is subtract the bigger number minus the smaller number. Keep in mind that we're doing the absolute value here, so that would be 14. 22 take away 14 is 8, and they have 8 written here. How do we decide it was a positive 8? Because 22 is bigger than 14 and 22 is positive, so 22 wins. It's going to take the sign of the positive number. Okay, to add 6 3/8 plus -14 3/4, first remember that these signs are opposite. Now, your calculator can handle this problem. So I don't want to emphasize this a whole lot when we're working these fraction problems, because I would imagine that most of you are going to use your calculators on this. But you'll notice that they did the same rule. The 14 is bigger than the 6, so they subtracted those. Okay, and they got 8 3/8. The 14 is bigger than the 6, so it took the negative sign. It's the same principle. Okay, to add -21.6 plus -9.8, these are both negatives, right? So the answer should be negative. and they took 21.6 plus 9.8 and then got their negative in the end. To work with sign numbers on a calculator, we need only one new key, the negative key. And remember, this is the one by the 0. It's not actually the negative or the minus sign. It's the negative key. This key allows us to enter a negative number on our display. So if we're supposed to add negative 587 plus 368, you want to hit negative 587, and remember that this negative is not the minus key, it's the negative that's by the 0, plus 368 equals negative 219. Excess electricity generated by solar panels can often be sold back to a power company. Over the course of a year, one particular homeowner using solar energy consumed the following monthly amounts of electricity according to her bill: negative 112, negative 42, so on and so forth. And a positive number means she purchased electricity, while a negative number means she sold electricity back to the power company. So we can calculate the net amount of electricity bought or sold during this period by adding the 12 monthly amounts. So they've just taken all of our numbers and added them together. You can see that they've grouped the positives together and the negatives together. You don't really have to do that. You could have just, let me go back up here really quick. You could have just typed in negative 112 plus negative 42 plus 86 plus 108. You don't have to group them together like they did, but that's what they did. And they got a negative 93 kilowatts. And because the net amount was a negative number, the electric company had to pay the homeowner. So she actually ended up making money on her electric bill. That would be great. So that's the end of section 1. We'll be covering section 2 next.